Hello, thanks for stopping by. I was watching one of Doug's videos the other day over on Moslack, and he had run into a couple of capacitors that he said were the wrong value. They must have been in the wrong compartment in the assortment that he got. And that got me thinking of a problem that I had run into. I take and try to buy, cheap Chinese components. I mean, it's just a hobby. I'm not fixing things for people or whatever. And some of the circuits I was looking at called for Zener diodes. So I took and ordered some assortments uh, from China. I got some half-watt ones and also some watt ones. I mean, they're dirt cheap, 300 for 255, and the bigger ones, 70 pieces of that for $1.65. You can't beat it. And I was putting together a circuit. It called for a 6.2 volt Zener. So I took and got out the package and opened it up. And if you ever try to read one of those, the print on them so small, even under a magnifying glass, you can't hardly read it. So they had each of the strips labeled. So I grabbed one of the 6.2s and put it in. And I was getting like 7.5 volts. And I said, this can't be right. So I got out, my super magnifying glass and looked at it, and here they were 7.5 volt. They had been labeled 6.2, and looking at the rest of them, the ones that they had labeled 7.5 were 6.2. So I got them all. They just had those two mislabeled. So I went looking around to see about throwing together a Zener diode tester. And there was a couple designs on the internet, and I took in pieces of all of them, put it together, and this is what I come up to. This is the basic design here. And of course, Bob, he's got a 555 DC to DC converter on it, but I'm not trying to take and regulate the voltage on this one, so it works fine. So we have the 555 timer with the 1K and 10K resistors, 1 nanofarad capacitor, and 100 microhenry inductor MOSFET. I mean, almost exactly like the circuit we were looking at the other day. The only difference is at the end of the 5819, there's a 30 volt Zener diode to keep the maximum voltage from going over 30 volts there. And this puts out more than enough current at that voltage for doing the Zener diode test. So I took and threw one together on a breadboard, and it looks something like this. It's everything that was in that other circuit. So let's try taking it out to the bench and testing it and see how well it works. Okay, let's see how well the circuit works on a breadboard. This is a 6 volt power supply powered by this battery. And I have a 10 volt Zener put in the test position. Let's press the button and see what happens. That particular one there is around 10.3 volts. That's one of the other problems with the Chinese stuff. You have to take, and there might be one that's exactly 10 volts, but you're usually not that picky where you have to have it exact. Let's try this. These are 5 volt. Put it in position. .23. Let's try one other one here. I see there's another one loose already. That one's 5.11. So they do vary. But then again, it beats paying 15 cents a piece for half watt and 25 cents a piece for 1 watt from like DigiKey or Mauser. And I've never bought them. I don't know whether they're going to be any more accurate or not. Let's try one of this. This is a 24 volt. Road range. It's only 4.2. So on breadboard it seems to work fine. Now let's figure on moving it over to a perf board. Make it a little more user friendly. Yeah, it seems to work really well. Now let's see about transferring it to perf board and see if we can't take and make it a little more semi-professional looking. Took and worked on it a little further, and I took and added a 6-volt power supply to it, since we need 6 volt. That way we can just take and run it off a 9-volt battery. I like to take and keep things portable, you know, so you just pick it up and carry it and use it. All you need is a 9-volt battery, the circuit, and a multimeter to take and hook up to it. So for power supply, I took and put an on-off switch LED so we know when it's on, and use a 7806 regulator with its associated bypass capacitors to give us the 6 volt for the circuit. And that feeds into our momentary contact switch. And the rest of it is basically the same as it was. Here's what it looks like assembled on the breadboard. You can see down where I have DUT, that's device under test. Those are 2 of those female round turn terminals that I like to use, and the voltmeter are 2 of the DuPont cable connectors or whatever to take and clip the voltmeter onto. But otherwise, it's exactly like the other circuit that we had. So let's take this out, hook 9 volts up to this, and see how well it does. Okay, let's try our finished product. Turn it on. And I have our 10 volt Zener in place. Press the test button. That seems to work fine. Our 5 volt one. See if I could take and hit the hole with it. Here we go. Let's do that here now. I think I messed up. Let's see here. That's a 24 volt one. Okay, and that read 24 volts. Okay. Now we have our 5 volt one. .2 volts. You'd probably do better if I had little like zero insertion force sockets instead of these. But if you, I mean, if you, all you got to do is really just, keep a finger on it to make sure you have good contact, and you're fine. So it appears to work just right. Okay, that just about wraps it up. Here's a copy of the schematic without all the notations and stuff on it. As you can see, it's a nice, simple, easy to put together circuit. Uh, the MOSFET, as long as it's an N-channel MOSFET, the MOSFET's really not that fussy. This is what I had laying around, in my collection and stuff like that. If you wanted to take and raise the voltage, you could take and use a 33 or 39 volt uh, Zener for D2 to take and, be able to take and, test a little bit higher voltages or whatever. So another piece of test equipment we can take and make on our own. Hope you enjoyed this little presentation. Thanks for stopping by. Have a good day.